Basics of signals. So signals is nothing but a mathematical representation of the physical phenomenon which contains some information, guys. So the thing is that the signal is the some kind of representation. What it will hold is that the physical phenomenon of the activity or physical phenomenon of the characteristic that it was given and which may contain some information. So for an example, if we take an AC voltage, so if we take the AC voltage as an example, so we know that AC voltage is a continuous time signal with the frequency hertz which is 50 and which will flow continuously. So the mathematical representation can be represented x of t which is equal to, so A which will be amplitude cos omega naught t. So we know that the frequency is 50, so that is here written as a 2 pi f. So omega which is equal to 2 pi f naught. So this is what frequency. So this is frequency. Frequency means the over the period of time how many times that it will change, that what the frequency will indicate. I will explain everything. So this is amplitude. So thing is that here it is a mathematical representation which is depend on some parameter t and omega naught and amplitude, which will be, which has some information that will be varied over the dependent parameters and independent parameters. So this is how the x of t can be called as a signal here. So this can be called as a signal. So why the thing is that, so it is a mathematical representation of the physical phenomenon. The current flowing is a physical phenomenon and which contains information that is frequency, amplitude, right? And also time parameter. So these all are some information that it has. So we can clearly state that. So this is also one kind of signal. So generally speaking, any mathematical representation which is varying with some phenomenon, we can represent that as a signals. So let us take the deeper dive into signals. Okay, signals. Let's take the thing. Signals is there. So a dependent variable with depends on one or more independent variable. So a dependent variable, a dependent variable which depends on one or more variables, one or more independent variables. So that this is another way we can call it. So let me explain it even deeply. So let's take a mathematical signal x of t which is equal to t square. Okay, so if you guys see, so this is signal x of t is signal. But if we take into, if we separate this into dependent and independent variable, so let me write the dependent variable is dv and independent variable is idv. So here what will be the dependent variable and independent variable? Please post in the comment section if you find the answer. So first thing is that we need to come from an independent variable. So here the t is independent variable. So because it can vary over any range. So t is independent variable. But the x of t is dependent variable. Because x of t which is constrained only to t square. So the x of t value can only be in this range of t square. So this is dependent variable. So this signal is dependent variable, but the independent variable will be t. Okay, so that is what the difference here. So if we take another one example, so x of lambda comma t. So these are two dependent variable which is equal to t square. So if you take the thing here, the same thing if you do here, so independent variable and dependent variable. So if we see independent, what are the independent variable means lambda and t, both can vary. This is independent, so it is not bounded. But the dependent variable is that x of lambda comma t. Okay, so thing is that the both are depend. The signal is depend on lambda as well as t. So that is what they are saying. So dependent and independent variable, you need to know the understanding of this. So if we relate both the thing here, we can call that as a signal. So a dependent variable. So signal is a dependent variable which depends on one or more parameters, one or more independent parameters. Okay, so that is what the another one definition of signals. So let us go through some important notations. So important notations. Okay, so let's take the first notation which is x of t. So we know that it is a signal, but here the dependent variable is x of t, the independent variable is t. So dependent variable is x of t, the independent variable is t. So this signal can be called as continuous time domain signal, continuous time domain signal. This will be continue because it's depend on t, so t is from minus infinity to infinity, and this is time domain signal because time only there, and this is time domain signal. Okay, so this is one first representation, that is x of t. So let us get into second notation, that is x of n. So we usually represent with the square braces. So here what will be the dependent variable and what will be the independent variable is the same thing, the independent variable n and the dependent variable x of n. So this n which is discrete time. Okay, I already stated. So even in I think in data converters in digital electronics courses I have taught this detailedly. So if you guys have any doubt over that, you can go and watch that, but let me explain here also. So thing is that the continuous time signal can be converted into discrete time signal with the help of sampling. So thing is that if the signal is continuous, for an example, let me take the thing. If the signal is continuous like this, okay, so this is continuous signal. If we need to change this into t, we need to sample the signals at some particular intervals, like this way. So if you take the interval which is equal to 1 second, then what will happen? N is equal to 1, n is equal to 2, n is equal to 3, 4, 5. So now what happened? This will be converted into n. So domain will be n. So the value will not be continuous. So value will be discrete. So only these samples will be there. So this is what the difference between x of t and x of n. So the value will not be continuous. So it is sample. If we done the sample, it will be discretized from the over the period of amplitude. So it will be discretized in time domain as well as over the amplitude. So that is what the meaning of the discrete time thing. So this signal can be represented as discrete time domain signal. So discrete, it's not a digital signal, guys. So it is discrete. So there is a lot of difference between digital and a discrete. So let me explain that also. Domain signal. So what is the exact difference between that is that, so this is discrete signal. So it will have a different pulse rate. So for an example, this value is 1, this value will be 2, so this value will be 1.5, this value will be 2.5, this may be 3, so anything. So the range will be different. But when we converted that into digital signal, what will happen is that the range will be only 1, will be 0 or will be 1. So only that is the thing. Means even the x-axis will be now be what you say means quantized means multiple ranges at the amplitude will not be allowed. So only few. I'm saying the 2 0 and 1, in some case even 0 2 some kind of things they will allow. So they will be sectionized to the amplitude value. So multiple values of amplitude will not be allowed. So only few values of output at the y-axis only will be allowed. For an example, that may be 0 or 1. For now you can consider like this way. So once that is they will fix a range. So for an example, if 1.5 is the range, so what are the amplitude which is above 1.5 will be considered as 1, what are the amplitude below the 1.5 will be considered 0. So then if you plot that, then here it will 1 1, then it will be 0, then it will be 0, like that way it will come. So like that way I am stating. So this is called digital signal. So there is a lot of difference between analog signal, discrete signal and digital signal. Okay, so I hope you guys are able to get it right. So let us go to the third notation. So third notation, which is nothing but x of omega. So here you see I use capital X. So even x of omega or x of f. So both will resemble frequency, right? So here the dependent variable is nothing but x of omega or x of f. The independent variable will be omega or even f. Okay, so there is a quite difference between both the thing. So that is continuous time angular frequency. This is continuous linear frequency, not a time. So this is angular frequency. So let me write it. So this will be angular frequency. I think you guys know because you guys will be completing mathematics, right? So if you guys not know, please make a note of it. So this will be angular frequency and this will be linear frequency. Even in physics classes, you guys have seen this, right? So this will be angular and this will be linear. So the relation is omega will be 2 pi f. Okay, this radian will be added in order to make that from the linear to angular. That is what the thing. Okay, so the unit of this will be radian divided by second. Okay, because the 2 pi is radian. Okay, the f will be hertz. So 1 by hertz is equal to 1 by second. So that is what we done here. So f is nothing but hertz or cycles per second. Cycle per second. So that is what the simple relationship between both the things. So this thing can be called as a continuous angular. We can add a continuous here. Thing is that it is not a time domain signal which is converted into linear frequency. It may be linear frequency or an angular frequency. It can be called as a continuous frequency domain signal. Continuous frequency domain signal. Okay, so this is also called a signal because it will have some information with that also dependent on some independent parameter. So that is what the thing is. So the last representation, which is, you guys can guess it, right? So x of n omega naught or x of n f naught. Okay, so this is how the thing. So here the independent variable will be the thing x of n omega naught or x of n f naught. The independent variable will be n omega naught or n f naught. The same thing. So this would both will be called as a discrete frequency. Both is called as a discrete frequency. Okay. So this can be called as a discrete frequency domain signal. So discrete frequency domain signals. So these are four representations, guys. So from here we are completing all our fundamental notation. So in next class I will be teaching what are the relation, how we can convert from one domain signal to another domain signal, what is the tool required for that, everything I will teach from next class. So today what we have seen is that, so what we mean by signal, so which is nothing but dependent variable which will be having dependent on some independent variable. So that is what the thing we see, and some basic definition of signal, and then some important notation which is continuous time domain signal, discrete time domain signal, and then continuous frequency domain signal and discrete frequency domain signal. I hope you guys able to understand few things here. So in going forward, each discussion I will be explaining more detail about what you mean by each thing. So how the frequency plot, how the time domain plot will be varying. So for now, the introduction and the importance of this thing for this thing will be fine for now. So in going forward, we will be discussing more detail on that. So stay tuned, guys. Thank you, guys.